Okay, it's going to be page 215 to page 216 for 8th grade. This shows the coordinate plane. Sketch the image after you rotate it 90 degrees and then dilate it. So if I'm going to rotate it 90 degrees, you kind of saw how the arrow was so that I could figure out where I was going to put it. And I'm dilating it 2 times. So that means that at the end, I'm going to be over 1, 2, 3, 4. 1, 2, 3, 4. Rotated 90 degrees. And then we're going to go up 1, 2, 3, 4. Just what we said. Over 4, up 4. 1, 2, 3, 4. That I'm matching with right here because this is -2, 2. So times 2, the opposite, right? Plus 4, 4. And then since they wanted me to dilate with with the factor of 2, and then I have to go up, we have to take into consideration how long this is. So the 2, this 2 is doubled, so it becomes 4. 1, 2, 3, 4. This is 1, 2, 3, 4. That gets doubled, so it's going to be 8. 1, 2, 3, 4, 5, 6, 7, 8. And then from there, we're just connecting it back together. Right, that's D. So I connected C with C. Perfect. All right, so it looks like that. All right, 2. The coordinates of this figure look like this. The triangle is cut in half. So if I have to cut all these in half, remember if we're dilating, that also means that you have to, so I'm keeping this, so this becomes -2. So I actually already know which one it's going to be based off my very first answer. -2, 2, 1, 2, 0, 1. Cutting everything in half. So C. If she chose A, then she mixed up. She thought that it was dilating. Maybe she thought it was dilating and that it had to change both X and Y coordinates. Sue thought dilating changed both the X and Y signs of the coordinates. Okay, because it changes the coordinates, but it doesn't change their sign. What I mean is that this is -2, right? We just divide it in half. It's not going to be a +2. So we thought dilating changed both the X and Y signs of the coordinates. Okay, so that is page 215. 216. A dilated image is always congruent. So if the size is changing, so that's not true. That's only true for our rigid translations. A rotated image, okay, this is rigid, so yes. A reflection is never congruent. No, it's this one is rigid. Rigid, 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 and rigid equals congruent. So this last one says it is always congruent. That's true. So we've got a nice pattern. False, true, false, true. Describe a sequence of transformations that maps these 2 polygons. So, they're there right here. So how can I get from here to here? We obviously have to have a dilation. You see that the size has changed. It's going from 2 to 3. So that's a scale of 2/3. So first we have to move, right? So dilate with a factor of 2/3 because we went from 2 to 3. So a factor of 2/3. And reflect. Here's our line. It is at y equals 1. And reflect at y equals 1. All right, so I made it smaller and then I reflected it. All right, find the perimeters of the two, then write the ratio of the perimeters and how does that connect to your scale factor. Okay, so perimeter 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's my area. This is 2, 1, 2, 3, 4, 5, 6. 6, 2, 6, 2. 6 plus 6 plus 2 plus 2. The other one is 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 plus 9 plus 3 plus 3. 12, 30, 40, 50, 16, 18, 19, 20, 21, 22, 23, 24 equals 24. So the ratio is correct because 16/24. Let's see, if we divide 16/24, what can we divide them by? We could divide them both by, oops, I did not write 24th. We could divide them both by 8. 16 divided by 8 is 2. 24 divided by 8 is thirds. So the ratio is equal and true. 16/24 can be reduced to 2/3. So that's page 215 and 216.